lab centrifuging can get kind of confusing. So here's a guide. The most confusing thing starting out, and something you want to make sure you have set correctly on your machine when you're setting things up, is whether you're dealing with RPM, revolutions per minute, or RCF, the relative centrifugal field. And so it's relative because it is relative to the force of gravity. So gravity G, sometimes we call this like the G force, so you'll see it like times G or something like that. That's where that's coming from. And that's talking about the force that's going to be applied on the molecules in the tube. And this force is going to help push the heavier stuff and the more like dense stuff. It's going to get pushed, it's going to travel faster through, and therefore it can like pellet out. So you get the solid collected here, or if you're going through some sort of a gradient, you can have things separate by their density or based on their like mass and size. So there are various types of centrifugation that we can do, but we're dealing with basic idea of this force being applied to the molecules and that making the molecules separate. We have to decide things when we're centrifuging, like how much force we want applied, and how much force we want applied is going to be specified, is going to be dictated by how fast the rotor is spinning, so the part that spins, how fast it is, and also how far the tube is from the center. So if you think about a tube and you start spinning it, there's going to be a force applied at the end. If I start spinning faster, that force is going to be greater. And if I lengthen the length of the string, that force at the end of the tube is going to be faster. So how much force is felt is going to depend on the speed, the RPM, as well as the distance from the center of the rotor, so like the radius. And this is why you can't just, knowing if you know the RPM, you don't automatically know the force that's being applied. But you can convert between the two if you also know the radius. So some rotors or some centrifuges, you change out the rotor and they're like really smart and they know what rotor you put in, or you tell it what you put in, and then it will do the conversion for you because it's got the radius programmed into it. Other times you have to do the conversion yourself, and it'll only be able to set it in the RPM because that's all that the centrifuge itself can do. It can control the RPM. It can't directly control the RCF because that's also going to depend on the rotor. But the basic idea is that once you know one of these, then you can convert between the two using there's like online calculators that you can use. There's also this thing called like a nomograph where you like basically you take the two things that you do know and you draw a line through them, and it'll like direct you to the third thing that you don't know. So whether that's the radius, that's the speed in RPM, or the speed in RCF. When it comes to swinging bucket rotors, often you'll see like the force, like the maximum force. That's because your tube is going to be like this. The maximum force is actually, you're going to have a different force felt throughout the tube. And so the maximum force is going to be here, and the average force is going to be here, and like the minimum or the average is like between these two. But typically it's given in terms of the max if you're trying to do some sort of conversion. So when it comes to centrifuges in the lab, there are several different types. The most obvious are like the size, and so you can have these little microfuges, these ones that you just use for these little pulse spins. But when you're actually doing something where you're controlling the speeds, then we can talk about having like a benchtop model or a floor model. And so your floor models are going to be for bigger things, and your benchtop models are going to be for smaller things. But both of these come in a couple different flavors of rotors, so the thing that's actually holding the tubes and spinning. There's swinging bucket, where there's actually buckets where the tubes are held in. With one of these, it's like one of those jellyfish rides where as it goes, then the tube starts going up to the point. And so when you pellet things, the pellet is actually going to be collected at the bottom of the tube. And so if this was a swinging bucket, it would be right here. Often when we're doing these little tubes, what we have is actually a fixed angle centrifuge. With these, your tube is typically held at like some sort of like between 20 and 40 degree angle. Different ones have different different angles, and your pellet is going to be at the top edge. There are also fixed angles that are like vertical, and then ones that are like slightly vertical. But the ones that we use the most often are something more like this. and so your pellet is going to be up here. So we often use these, the swinging buckets we have like a lot of times the common benchtop ones that we use to spin down various like Eppendorf or the bigger like Falcon tubes and things like that. Those are often swinging bucket. When we talk about the microcentrifuge tube centrifuges, those are typically just like fixed angle. And when we use both of those for like pelleting. So when you have a really big difference between the densities and between the masses of the things that you're trying to separate, that'll kind of do like a bulk separation. And so this is really helpful if you like lyse open cells and then you want to get rid of the cell gunk, or you want to pellet out any sort of insoluble stuff. But when you're actually wanting to like pellet out or separate out different proteins or different complexes, different organelles, things like that inside of cells, then we turn to things where we're going faster with the ultracentrifuge and we're using some sort of gradient. So rather than just having it go through whatever buffer it's in, it's going through some sort of gradient, maybe like a sucrose gradient, a cesium chloride gradient, gradients like this, which are going to then separate things out better. And typically those are done in these swinging bucket centrifuges, but not always. Buckets are good for these gradients because you're going to get the longest length. So when that tube goes horizontal, you go through the whole tube length, rather than if it's at an angle, it's going to be only partial through the tube length. It's kind of like for size exclusion chromatography, how the longer your column is, the better the separation. Same sort of thing. The longer your distance of the gradient, the more you can spread things out. That is one of the differences of things. And then we have the difference of speed. So we can talk about just like these normal centrifuges, which can go up to a certain speed, and then we have ultra centrifuges, which go super duper fast. So with these ultra centrifuges, we're getting up to like 40,000 RPM, 70,000 RPM, 100,000 RPM, these really, really crazy amounts. And so there's going to be a lot of force on these little tubes. And so for those, you want to make sure that you're using special tubes and things like that. I'm planning to do a practical post on more about using these various centrifuges, but today I just wanted to tell you more about some of the basics for using them. With these different rotors, you might wonder like, okay, well, how fast can this rotor go? You can look at the lid typically of these rotors, especially for the ultracentrifuge rotors, and they'll say things like, if they say type, that is going to be a fixed angle. If they say like something with an S or an SW, that's going to be a swinging bucket. And then there's going to be like a number. That number is typically telling you about how fast it can go. So for example, a type TI 45 or 45 Ti, I can never remember which way they actually say it, but basically that is type tells you it's a fixed angle. The 45 is telling you that it can go up to 45,000 RPM. And then the Ti, that's for titanium, which is like their strongest metal that they use to make these. They also, if you see like a C, that's a fiber composite. If you see a AC, that's going to be like an aluminum fiber composite. And if it doesn't say, then it's likely an aluminum alloy, so some sort of aluminum with other mix of stuff. You might also see some different shapes of the centrifuges. When you have these like heavy metals, it can get, not like heavy metals, but like they're heavy. Like it's heavy to pick up the centrifuge. So sometimes to make it easier, they actually like flute things, so they like bevel out in between, bevel the right word, I don't know, in between the different like buckets, so that it's easier to use. When you're using any of these centrifuges, you need to make sure that you're balanced. So as you can see, like if one of this is when you have force being applied, well, if there's no other force being applied, then it's going to go, which you don't want. So the centrifuge is smart, and it's going to tell you there's an imbalance typically before that happens. But to make things balanced, you need to have an equal thing opposite of it. And so if you have an equal number of tubes, they're going to be across from one another. And if you have like 3 or something, you can space them out evenly, and more on spacing out in other posts. But when you're going out the faster you go, the more important it's going to be that you're really balanced. With little things, it's not as big of a deal, but when you're dealing with like ultracentrifuges, you want to make sure that you're doing it really carefully, and I'll do more on this in a practical post. But that's basically the basics. So remember that the force that's being felt, we often talk about this as like the G force, because it's felt, it's given the relative centrifugal field is going to be relative to the force of gravity. And often you see it in like without the thousands. So if you see something like 40, that's not really going to be like 40, it's going to be 40,000 G. And that's going to depend on both it's going to depend on the rotor and the speed at which that rotor is moving. And so the further away you are, the longer the radius, the bigger the force that's going to be applied. So the main things that you have to choose are going to be what centrifuge you're using, what rotor you're using, what speed you're using, what temperature you're using. For the speed and the temperature and things, you can get those based off of protocols, and then really the size and things depends on the size of your sample. But those are just the basics of these lab centrifuges, and hope that that was helpful. And remember, balance, like all things in life, keep balance.